In this video I'm going to look at finding the missing side using trigonometry. So we would use trigonometry if you've got a right angle triangle and you know at least one angle and one length and you want to find one of the other lengths. So the trigonometry rules are sin x equals the opposite length over the hypotenuse, cos x equals the adjacent length over the hypotenuse, and tan x equals the opposite length over the adjacent length. So let's put this into practice in some examples. So the first one, we've got a right angle triangle. We know the angle is 52 and we've got a length of 6 and we want to find one of the other lengths. So the first thing we do is label the sides, the hypotenuse, which is always the longest side, h, the adjacent length, which is always the length next to the angle, here, and the opposite length, which is always the length opposite the angle, here. So when we look at what we've got, we know the opposite side and the hypotenuse. So therefore, if we look at the rules, the rule that uses O and H is sine, so we're going to use sine x. So if we put that into the equation, we've got sine 52, because that's the angle, is equal to the opposite length, which we know is x, over the hypotenuse, which we know is 6. And when we rearrange that, because 6 is on the bottom, it's divided by 6. Therefore, when we move it to the opposite side, it becomes times. So therefore, we can rewrite this as x is equal to 6 times by sine 52. Okay, and when we put that into a calculator, we get that x is equal to 4.7 to 1 decimal place. Okay, let's look at another example. In this example, we've got the angle 76 and we know one of the lengths is 10 and we need to find one of the other lengths. So first of all, let's label the sides again. So we've got the hypotenuse, the adjacent length and the opposite length. So when we look at what we've got, we know O and A. So the rule that uses O and A is tan x. So let's substitute in everything we know. So we've got tan 76 is equal to O, which we know is x, over A, which we know is 10. And rearranging this, we get that x is equal to 10 times by tan 76. And when we put that into the calculator, we get that x is equal to 40.1 to 1 decimal place. Okay, now let's look at a different type of example. So again, first of all, label the sides. So we've got the hypotenuse, the adjacent length and the opposite length. And we know that the angle is 63 this time. So let's look at which rule uses A and H. When we look across, we can see that cos uses A and H. So let's substitute in everything we know. So we've got cos, the angle, which is 63, is equal to A, which we know is 8, over H, which we know is x. So this time x is on the bottom. So because of the divide, because it's divided by x, we want to move that to the other side. So when we do that, we get that x times by cos 63 is equal to 8. But we want to get x by itself. So therefore, because it's times, when we move it to the other side, we get divide. So therefore, x is equal to 8 divided by cos 63. Okay, and when we put that into the calculator, we get that x is equal to 17.6 to 1 decimal place. Right, let's look at our final example. Again, label the sides. So we've got the hypotenuse, the adjacent side and the opposite side. And when we look at the information we've got, we know O and A, and therefore we need to use tan x because that uses O and A. So let's substitute that into the equation. We get tan 47, because that's the angle, is equal to O, which we know is 12, over A, which we know is x. And a bit like the previous example, because x is on the bottom, so it's divided by x, when we move that to the other side, we get x times by tan 47 is equal to 12. But we don't want the tan 47 there, we want to get x by itself, so therefore we need to move it to the of the side, so the opposite of times is divide, so that becomes x equals 12 divided by tan 47. And finally, if we put that into the calculator, we get that x is equal to 11.221 decimal place. So I hope that has been helpful to you.